Good morning, respected ma'am. I am Charanya from AIML A section department and my roll number is 38. Today I am presenting about what is symmetry in crystal. What is symmetry in crystal? Introduction for what Introduction to crystal system symmetry. Crystal symmetry refers to the order, repetitive arrangement of atoms within a crystal. It plays a fundamental role in determining the physical and chemical properties of matters. Understanding symmetry helps in classifying and understanding different types of crystals. This is the reference image of introduction to crystal symmetry. What is a crystal? A crystal is a solid material whose atoms are arranged in an orderly, repeatedly pattern. The repeating pattern exists in all three spatial dimensions. This periodic arrangement results in the characteristic space and properties of crystals. This is the relevant image for this topic. Definition of symmetry in crystal. Definition of symmetry in the crystal. Symmetry in crystals refers to the invariation of crystal structure under certain operations. This operation includes rotation, reflection, translation, and invariations. When a structure looks the same after a symmetry operation, it is said to possess that symmetry. This is the relative nature of symmetry in crystals. Type of symmetry elements. Symmetry elements are geometrical entities about which symmetry operations are performed. Common symmetry elements includes axis of rotation, mirror planes, and center of inversion. The combination of these elements defines the overall symmetry of a crystal. This is the relevant picture for types of symmetry elements: cubic, trigonal, orthorhombic, hexagonal or trigonal, tetragonal, monoclinic, triclinic. Next, rotation axis in crystals. Rotation axis are line about which a crystal can be rotated by a certain angle and look and changed. The order of the axis indicates how many times the structure repeats during a 360 rotation. 360 degrees rotation. For example, a four-fold axis means the structure repeats every 90 degrees rotation. This is the relevant image for rotation axis in crystals. Mirror plane and reflection. Mirror planes are flat surfaces dividing the crystal into two mirror image Dividing the crystal into two mirror image hands. Reflection symmetry occurs when a part of the crystal is mirror image of the other. The presence of mirror plane influences the crystal's optical properties. This is the relevant image for mirror planes and reflection plane mirror characterize of images. Inversion center in crystals. An inversion center is a point in which within the crystal where all parts are symmetry with respect to it. If a point is inverted through this center, it maps onto an equivalent point in the structure. Inversion symmetry affects the overall symmetry and classification of crystals. This is the relevant image for inversion center in crystals. Translational symmetry. Translation symmetry involves shifting the entire crystal structure by certain vector. The crystal appears unchanged after such a translation, indicating periodicity. This symmetry leads to the concept of a lattice in crystal structure. This symmetry leads to the concept of a lattice in crystal structure. This is the relevant image for the translation symmetry. Crystal lattice and unit cell. A lattice is an infinite array of points representing the periodic structure of the crystal. The smallest repeating unit, called the unit cell, embody the symmetry of the entire crystal. The shape and symmetry of the unit cell are circulate in classifying crystals. Crystal lattice and unit cell. The relevant image for crystal lattice and unit cell. Next one. Symmetry operations and point group. Symmetry operation includes rotation, reflection, inversion, and row reflections. Point groups are classification of crystals based on the symmetry operations that leaves at least one point fixed. There are 32 distinct points groups in three-dimensional crystals. This is the relevant pie chart for symmetry operations and point groups. Space groups and symmetry. Space groups combine point groups symmetry with translation symmetry. They describe full symmetry of a crystal three-dimensional structure. There are 230 unique space groups used to classify all crystal structure. This is the relevant picture for space groups and symmetry. Space groups and symmetry. Next one. Importance of symmetry in crystals. Symmetry influences physical properties such as optical activity and conductivity. aids in predicting and understanding crystal growth and behavior. Knowledge of symmetry is essential in material 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 science and crystallography. So this is the relevant image for importance of symmetry in crystals. Symmetry and crystal classification. Crystals are classified into several crystal systems based on their symmetry elements. Their system arranged for triclinic to cubic, reflecting the degree of symmetry. Symmetry symmetry consideration helps in identifying and comparing different crystalline materials. So this is the relevant image for symmetry and crystal classification. Applications of crystal symmetry. Symmetric principles are used in designing new materials with specific properties. This assigns in diffraction patterns. In crystallography, understanding symmetry is fertile for developing parametrics, electronic and nanomaterials. This is the relevant image for applications of crystal symmetry. The last slide, crystals conclusion. Symmetry in crystal describes the invariation of structure under specific operations. It is fundamental to understand the physical, chemical and optical properties of materials. Mystery of symmetry concept enchants the study and applications of crystal substances. Thank you.